Find the radical center of x square plus y square minus 4x minus 6y plus 5 equal to 0, comma x square plus y square minus 2x minus 4y minus 1 equal to 0, and x square plus y square minus 6x minus 2y equal to 0. Given circle, this is the first circle and the second circle and the third circle. Now we are going to find the radical center. We know that the equation of the radical axis, first we need a radical axis of each pair, right? 1 2 2 3 and 3 1. Then the point of intersection of all these three line radical axis gives the radical center. So we have to solve any two radical axis, right? So first we have to find the radical axis. We know the radical axis of two circles, x square plus y square plus 2gx plus 2fy plus c equal to 0, and x square plus y square plus 2g1x plus 2f1y plus c1 equal to 0 is 2 into g minus g1x plus 2 into f minus f1y plus c minus c1 equal to 0. So 1 implies we are going to find g, f and c, right, from first equation. 2g is equal to minus 4, g is equal to minus 2, 2f is equal to minus 6, f is equal to minus 3 and c is equal to 5. 2 implies 2g1. We are taking g for first equation and g1 for the second equation, right? We are going to find the radical axis, right? 2g1 equal to minus 2, g1 equal to minus 1, 2f1 equal to minus 4, f1 equal to minus 2, c1 equal to minus 1. The equation of radical axis of 1 and 2 is 2 into substituting the values minus 2 minus minus 1 into x plus 2 into minus 3 minus minus 2 into y plus 5 minus minus 1. So you will get minus 2x minus 2y plus 6 equal to 0 divided by minus 2, so you will get x plus y minus 3 equal to 0. That is equation number 4. Now next 3 implies 2g2. We are taking g2, right, for third equation, right? 2g2 is equal to minus 6, g2 is equal to minus 3. Similarly f2, right? 2f2 is equal to minus 2, f2 is equal to minus 1, c2 equal to 0. So radical axis of 2 and 3 is 2 into substituting the values, right? g1 minus g2, right, into x plus 2 f1 minus f2 into y plus c1 minus c2, substituting all the values. 2 into minus 1 minus of minus 3 into x plus 2 into minus 2 minus of minus 1 into y plus minus 1 minus 0 equal to 0. After simplification you will get 4x minus 2y minus 1 equal to 0. That is equation number 5. This 2 enough, right? We can solve 4 and 5, then you will get the radical center. So however we are going to find the radical axis of 1 and 3 also, right? So 2 into minus 2 minus 3 into x, that is g minus g2, 2 into g minus g2x plus 2 into f minus f2y plus c minus c2, right? 2 into minus 2 minus of minus 3 into x plus 2 into minus 3 minus of minus 1 into y plus 5 minus 0. So after simplification you will get 2x minus 4y plus 5 equal to 0, that is 6. So to find our aim is to find the radical center. We know the radical center is the point of intersection of radical axis. To solve any two equation from 4 5 6, right? So we are taking 4 into 2, 2x plus 2y minus 6 equal to 0. We are taking the sixth equation, right? So you can take 5 also, you can solve, right? You can take any two pair, right? 4 5 5 6 or 6 and 4. Solve for x and y. That is the radical center, right? 2x minus 4y plus 5 equal to 0. So subtracting, change the sign, right? So 0 plus 6y minus 11 equal to 0. 6y equal to 11, y is equal to 11 by 6. Put y is equal to 11 by 6 in 4. So x plus 11 by 6 minus 3 equal to 0. So taking 6 as LCM and do the cross multiplication, right? 6x plus 11 minus 18 divided by 6 equal to 0. 6 into 0, 0. So you will get 11 plus 6x minus 18 equal to 0. 6x minus 7 equal to 0. 6x is equal to 7. X is equal to 7 by 4. Therefore the radical center is 7 by 6 comma 11 by 6. The above problem, to find the radical center, it is enough to find any two radical axes and not all the three, right? Next problem, show that the circles x square plus y square plus 2ax plus c equal to 0 and x square plus y square plus 2by plus c equal to 0 touch each other if 1 by a square plus 1 by b square equal to 1 by c. Given circles are, first circle x square plus y square plus 2ax plus c equal to 0. The second circle x square plus y square plus 2by plus c equal to 0. 1 implies we are going to find the coefficient of x, y and constant term. 2g1 equal to 2a, g1 equal to a, f1 equal to 0, c1 equal to 0. C, right? And from equation number 2, we are taking g2, f2, c2. 2g2 equal to 0, g2 equal to 0, 2f2 equal to 2b, f2 equal to b, c2 is equal to c. Center of 1 is c1 minus g1 minus f1, that is c1 center minus a comma 0, and the radius of 1 is root of g1 square plus f1 square minus c1, that is equal to root of minus a square plus 0 minus c, so root of a square minus c. The center of 2 is c2 minus g2 minus f2, that is it. c2 is 0 comma minus b. Radius of 2 is r2, that is equal to g2 square plus f2 square minus c2, that is equal to b square root of b square minus c. We know that two circles are respectively with center c1 c2 and the radius r1 r2 touching each other if c1 c2 is equal to r1 plus r2. This is what we know, right? So here c1 c2 is equal to root of 0 minus minus a the whole square plus minus b minus 0 the whole square, root of a square plus b square. Now c1 c2 is equal to r1 plus r2. We are using that condition. Root of a square plus b square equal to r1 we know, root of a square minus c, and r2 is root of b square minus c. Squaring both sides, root of a square plus b square the whole square is equal to root of a square minus c plus root of b square minus c the whole square. So when we are squaring, square root will go, so a square plus b square on the left hand side. Right hand side you are using a plus b whole square formula. So a square, so square root will go, so a square minus c plus b square minus c plus 2 into root of a square c minus b square c. So minus a square on right hand side, b square on the right hand side will get cancelled with a square plus b square on the left hand side, right? So remaining term, so minus 2c, c minus c minus c minus 2c plus 2 into root of a square minus c root of minus b square minus c equal to 0. So 2 is common, you can cancel these 2 also, right? So remaining minus c plus root of a square minus c root of b square minus c equal to 0. Taking that c from the left hand side to right hand side, you will get root of a square minus c into b square minus c equal to c. Again squaring both sides. So root of a square minus c into root of b square minus c the whole square equal to c square. So square root will go, a square minus c into b square minus c is equal to c square. So multiplying a square b square plus c square minus a square c minus b square c equal to c square, right? So c square get cancelled, remaining a square b square minus a square c minus b square c equal to 0. That is a square c plus b square c is equal to a square b square. So divided by a square b square c. So a square c by a square b square c plus b square c by a square b square c, which is equal to a square b square by a square b square. So a square c get cancelled in the first term, b square c get cancelled in the second term, which is equal to a square b square get cancelled. So remaining 1 by a square plus 1 by b square equal to 1 by c, which is to be proved. Thanks.